Hey guys, it's Mr. Settles talking to you from my living room. We want to talk to you today about probability. And I know that you went through all the other videos that Ms. Cavendish has sent in, and she did those in a different way than I'm doing this. I'm kind of forced into doing this because I can't get into school today to give you this instruction. So bear with me today. I'm in my living room, which has kind of been turned into a rehearsal hall for my band because we can't play out because of the coronavirus. I hope you all are staying safe during all this. I know it's a tough time, but just bear with me today. I don't have a lot of technology here, so I can't do whiteboards and all that, but I do have a computer that I have some stuff on, and I have some stuff written down on paper. I'm going to try to talk to you about SOL 7.8, which is the last SOL that we have to deal with this year. Ms. Cavendish went through everything with histograms and stem and leaf and plotting results. Today, I'm going to be working with you on experimental and theoretical probability. And the biggest thing with probability that you have to remember is probability is basically what you there's two types, experimental and theoretical. Theoretical sounds like theory, doesn't it? Okay, it's derived from that word. Theoretically is what you think is going to happen. Experimental probability is what happens when you actually do it in real life. Now, I'm going to put these definitions up on the board on this computer just for a second for you guys to look at. You don't have to copy this down. I just want you to think about it because a lot of probability is just common sense. So I'm going to show you these, and this is a little wacky because I've got a computer here that you've got to read from a computer to a computer. But experimental probability is the ratio of the number of times an event occurs to the total number of trials times the activity is performed. And I'm trying to read this backwards on the screen. But then what that basically means is how many times something happens when you actually do an experiment. Theoretical probability is the probability that a certain outcome will occur as determined through reasoning or calculation. I'm going to give you a couple of quick examples, and we're going to talk about this. And the easiest way to think about probability is, let's look at, we got a coin here, right? And we're going to flip this coin. Now, anytime you get ready to flip a coin, what do you think the chances are that it's going to land on heads? Well, the first thing you have to do is say, how many possible outcomes are there? Well, there's heads and there's tails. There's two possible outcomes. If you want to figure out how many times you think, what's the probability it's going to land on heads, that's 1 out of 2, or 1 divided by 2, which is 50%. Half the time you think it's going to land on heads, half the time you think it's going to land on tails when you flip it, okay? So the theoretical probability, in theory, when you flip a coin, there's a 50% chance it's going to land on heads and a 50% chance it's going to land on tails. Now, I'm going to show you now what the difference between theoretical probability, which is what we just talked about, 1 out of 2, 50%. We're going to compare that to the experimental probability. I'm going to flip this coin 5 times, all right? And I'm going to record what happens. And you can go along with me at home. I'm going to flip the coin the first time. Here it comes. It just landed on heads. So I record heads 1 time. Let's flip it again. And this is an experiment, right? We're doing this experiment. This is experimental. Let's flip it again. Here it is. Tails. Let's flip it again. Heads. So I've got 2 on heads, 1 on tails. 4th flip. Tails. The funny thing is so far, we flipped it 4 times. 2 times it's landed on heads, and 2 times it's landed on tails. So the experimental probability, what we just did, is the same exact thing as the theoretical probability. It's landed on heads half the time. But now we're going to do the 5th flip. We flip it again. This time it lands on tails. Okay? So we've had 3 times it's landed on tails, and 2 times it's landed on heads. Okay? So the theoretical probability is 50%. And anytime you see in a question, if somebody can tell you, we flipped the coin 10 times and it landed on heads 10 times, what's the theoretical probability the next flip will be heads? Well, it's always 50%, because in theory, the next flip is always going to be 50%. Now, when we deal with this experiment that we just did, 2 out of 5 times it landed on heads. So if you put in your calculator 2 divided by 5, you get 40%. So the experimental probability that it lands on heads is 40%. Even though in theory it should have been 50%, when we actually did the experiment, it was only 40%. And the experimental probability it landed on tails was 3 out of 5. If you put that into your calculator, it's 3 divided by 5 equals 0.6 or 60%. Okay, so if we're looking at what we just did with the experiment, we say the experimental probability it lands on heads is 40%. The experimental probability it lands on tails is 60% because it was 3 out of 5 times. That's the difference between a theory and an experiment. When you actually do the experiment, the numbers are usually going to be different than the theory. Now let's look at something else. Let's look at a spinner. I'm going to show you this spinner, and once again, I apologize for my lack of technological advancement here, but this spinner, we're going to look at the spinner, and you can just figure there's a little thing here and we're going to spin that. And a quarter, so you've got it divided into 4 equal sections: red, blue, green, and yellow. So when we think about what's the theoretical probability that when you flip that spinner, it's going to land on one of those numbers, on one of those colors. There's 4 colors, and they're equally spaced on that spinner. So it's a 1 out of 4 chance for each color. So when we flip that spinner, in theory, 1 out of 4 chances it'll be blue, because you see that blue is 1/4 of the chance here. Red is 1 out of 4, 25%. Yellow is 1 out of 4, 25%. And green is 1 out of 4, or 25%. There's a 25% chance, in theory, when we flip that spinner, it's going to land on any one of those 4 colors. All right? Now, I've got a little spinner here, but there's no way for me to hold it up. But I'm going to spin it right now, and I'll tell you what it comes out to. This is the experiment. We just said that what's the theory? Each color has a 25% chance. Now we're going to do the experiment. So I flip it the first time, and it lands on yellow. Flip it the second time, lands on yellow again. I'm going to flip it the third time, lands on blue. I'm going to flip it the 4th time, it lands on green. And I'm going to flip it the 5th time, and it lands on blue. So we've done our experiment. Now we need to record our results. Now remember, in theory, we said each color had a 25% chance. All right? I'm writing this up in the corner. The theoretical probability of it landing on any color is 25%, or 1 out of 4. Now here are the spins. We went yellow, yellow, blue, green, and blue. So the totals here, how many times did it land on red? 0 out of 5 spins. On green, it was 1 out of 5 spins. Blue, it was 2 out of 5 spins. And yellow was 2 out of 5. So when we put these percentages together, we're going to say when we actually do the experiments, 0 out of 5 times it landed on red, so the experimental probability it landed on red was 0%. Even though in theory we thought 25% of the time it landed on red, it really only landed in the experiment 0 times, so it's 0%. So if somebody asks you a question, if you have a spinner with 4 colors and you spun it 5 times and it didn't land on red at all, is the experimental probability greater or less than the theoretical probability? Well, it's less, because it only landed on it 0 times, which is 0%. That's less than what you think would have happened. Green, 1 out of 5 times, 20%. That's a little less than what you would have expected. When we did blue here, it was 2 out of 5. which is 40%. 2 divided by 5 is 0.4. You guys should know how to convert decimals to percentages 40% of the time. So that's greater, the experimental probability was greater than the theoretical probability. Here, when we did yellow, that was also 2 out of 5 or 40%. Okay? So this probability was higher than the theoretical probability. All right? Now, I'm going to show you one more thing with probability. We're going to work with, say, the person has a bag of marbles. All right? Now, when this person has a bag of marbles, and I've got a little bag of marbles here that I'm going to be choosing from, in this bag of marbles, there are 10 blue marbles, 10 purple marbles, 15 green marbles, and 15 yellow marbles. The reason why I put this down here, 50, that's the total number of marbles that are in this bag that I've got down here. All right? So when you say the experimental, theoretical probability, it's going to be 10 out of 50 that it's going to land on blue. The theoretical probability that's going to land on purple is 10 out of 50. The theoretical probability it's going to land on green is 15 out of 50. And the theoretical probability is going to land on yellow is 15 out of 50. So I'm going to write these numbers down and say the experimental probability is 10 out of 50 or 20%. Excuse me, the theoretical probability, I made a mistake there. Sorry about that, guys. This is a tough gig out here in COVID-19 land. So you do make mistakes every now and then. 10 out of 50, 20% chance. In theory, same with purple, 10 out of 50. 20% chance it's going to be purple. Green marbles, there's 15 out of 50. That's going to be a 30% chance. And same with yellow, 15 out of 50. That's 30%. All right? Notice that all of these add up 20, 20, 30, and 30 to 100%. So in theory, you take the amount of marbles divided by the total number to get the theoretical probability. That you think that 20% of the time you reach this bag and grab a marble, it's going to be blue. Same with purple. Green and yellow have a little higher probability because they're 15 out of 50 instead of 10, so there's a 30% chance you'll pick one of those two. So I'm going to actually reach in this bag, and I'm going to do 10 trials here. So I'm reaching in, I'm grabbing the first marble is a blue. Reaching in for the second marble, and I'm putting the marbles back in as I pull one out. I'm just saying out of 50. Each time is going to be out of 50, so when I pull one out, I'm putting it back in. And we'll talk about that in the next lesson with replacement and without replacement. But right now, we're replacing the marbles because there's 50 in the bag every time I do this. Second one's purple. And the third one is blue again. And again, yellow. Fourth trial, and see, like I said, this is an experiment. We're actually doing this. This is not a theory, what we think will happen. This is what has actually happened. Reach in again. We've got a green marble. We'll do 5 more of these, and I don't mean to bore you, but we're trying to give you a point here, show you how you do this. Blue. All right, next one is green. Next one is green. Get back in, draw another one. This one is yellow. And this next one is blue. That's the last one. All right, so I've recorded the 10 trials. Blue, purple, blue, yellow, green, blue, green, green, yellow, blue. So when we put all our numbers together, we had a theoretical probability of 10 out of 50 or 20%. When we actually did the experiment, I'm sorry I put this on the wrong side the first time. Blue marbles, we went 1, 2, 3, 4 out of 10. There were 4 out of 10 times that we drew a blue marble. That's 40% of the time. Purple marbles, 1, and that's it. 1 out of 10. Or 10%. Green marbles, we go through 1, 2, 3. That's 3 out of 10, 30% of the time. And finally, yellow, 1, 2, 2 out of 10, or 20%. All right? So when you look at this, we look at the experimental probability of drawing a blue marble was 40%, because 4 out of 10 times we drew a blue marble, but we would only expected that to be 20%. In theory, it should have only been 20% of the time, but when we actually did it, it was almost twice that much, and that'll happen sometimes. All right, purple marbles, we thought there was a 20% chance you get a purple marble. Well, we only pulled out 1 out of 10, so in the experiment, it was only 10%. Green marbles should have been 30%. Well, we pulled 3 out of 10 out. The experimental probability was exactly what we thought would happen in theory. So every now and then, it does work out to be exactly the same. But usually in an experiment, it won't be the exact same amount as what it is in theory. And the last one was yellow marbles. We thought it was going to be 15 out of 50 or 30%. The theory was 30%. It was only 2 out of 10 times of 20%. So listen, we got a worksheet for you. You guys try to do it. Me and Ms. Cavendish have been talking about the grades. You got to get all your study island assignments done. I'm just putting the first 10 of those in the grade book, and I'm not sure how Ms. Cavendish is doing it, but you need to do this online work. And if for some reason by this point in time you haven't gotten a computer from school, if you don't have one, please call the school and get one. They'll lend one out to you, but they have to be returned by June the 1st. So even if you haven't even started on the study island assignments, if you get on them now, you can knock them out pretty quickly, because everything that's on there, except for what we've discussed on these online classes, all the other SOLs, it's just review for you. So it should be pretty easy. And they have a little part at the end of each section where you do 10 questions and you answer those questions. And I'm just counting the highest grade where you can take them as many times as you want to. But anyway, if you have any questions on this, email me or Ms. Cavendish. I'm doing Teams meetings every Wednesday, somewhere between 9 and 1 in the afternoon. Ms. Cavendish is doing meetings. So we want you guys to contact us if you have any questions on this. Also, spread the word around that this work has to be completed. If you don't do any work, you're not going to pass for this last 9 weeks. And all you have to do is, they're pass-fail grades, all you have to do is get a 59.5% to pass for the last 9 weeks. But please spread the word, tell your fellow classmates, hey, you got to get this online stuff done. And I'm letting my students work together if you want to. If you want to get together and get a couple computers together or work on these together, that'd be great. But the work's not that hard. You can knock it out fairly quickly. And you've got till June the 1st to get it done. But you need to get it done, okay? I want you guys to stay safe, be cool. We'll see you next time.